Okay, this lesson is on algebraic domain. In other words, looking at something and figuring out what the domain is algebraically. And really we're going to focus on two situations. One is fractions and the other is radicals. With fractions, your domain has to be anything except what gives you a 0 in the denominator. So if the bottom of the fraction is 0, when you plug that number in, that number is not in the domain. So our first example, I have f of x equals 1 over x. Now this is on your toolbox function list. You should know what the graph looks like so you can verify your answer by looking at the graph. But here, the only thing that I could plug into the denominator and make the denominator 0 is 0. And so my domain would be all real numbers not equal to 0. Now, if you don't like that kind of notation, which I feel is the easiest way to write this, you can write the old school notation and say from negative infinity to 0 and from 0 to infinity. But obviously you don't have the square brackets around the zeros because you don't want to include the 0. That's the other way to write this, but to me the fastest way is just all real numbers not equal to 0. Okay, so for example 2, you may be able to just think about it, and some of you may say, well, if I plugged in 5, then I would have 5 minus 5, and that's 0. And so that's a quick way to get it. And so 5 cannot be a member of your domain. So again, I would write my domain is all real numbers not equal to 5. And so it would be everything from negative infinity up to 5, and then everything on the other side of 5 to infinity if you needed to think about it that way. Now, I threw number 3 in because a lot of people cannot think about what you would plug in to get a 0 on the bottom because it's just not as clear as number 2. And so what happens when you can't figure it out is you do some scratch work. And so my scratch work would be setting the bottom equal to 0 because that will tell us when you would get a 0. And if I do that, I can just solve. So I'm going to subtract 1 and divide by 2. And so that tells us when that I could plug in and get a 0 on the bottom. And so this number is not part of my domain. This is what makes this one a little bit harder is because you have a fraction. But again, think about it. If I did 2 times negative 1/2, I would get a negative 1. Plus 1 would be 0. So my domain can be everything not equal to the negative 1/2. Example 4 is another situation that you can't quite just see. So do your scratch work again. I have x squared minus 3x set equal to 0. This is a quadratic, so I can actually factor that, and I have x and x minus 3 if I factor out a GCF. And in this case, I have either x equal to 0 or x minus 3 equal to 0, solving that quadratic out. So this is one of my answers, sort of. We're not there to the domain part yet. And then if I add 3 here, I get x equals 3. What that means is there isn't just one number I can plug in and get a 0, there's actually 2. If I plug 0 in, 0 squared minus 3 times 0 would be 0. And if I plug 3 in, 3 squared would be 9, minus 3 times 3, which is 9, that would give me 0. So my domain would be all real numbers not equal to 0 or 3. Those cannot be in there. Now, if you were having to write that out in the old notation, you would have you would have negative infinity to 0, 0 to 3, and 3 to infinity. You would have 3 sections of the graph because it would have all the x values except those 2. And again, you have to use the parentheses on the 0 and the 3 because you cannot include the 0 and the 3. Okay, so example 5 is also a fraction. And again, the bottom is not something that you necessarily can look at and tell what would make it 0. And you might think of plugging a negative 2 in or something like that. But notice, if I set the bottom equal to 0, and I try to solve that, first of all, this is not factorable. This is not a difference of perfect squares because it has a plus. If I try to solve that, if I subtract 4, and then I take the square root, I have the square root of a negative 4, which would be positive and negative 2i. And what we're trying to find is the domain. And so we're not going to be worrying about i's when we're figuring out the real numbers in the domain. Because I got i's as my answer, that means that this graph does not skip anything. It has a domain of all real numbers. And if you want to, graph it and look at that graph, and you will notice it is continuous all the way from the left to the right. It does not jump over anything. But that is a weird one. It's a good one to bring up. Okay, now we're going to focus on square roots. And the thing about those is, to be in the domain, the inside has to be greater than 0. We don't want any imaginary numbers here either. And the way that you get imaginary numbers is by having the square root of a negative. So the inside has to be greater than or equal to 0. Now, you can equal 0 when it is a radical by itself, because that's allowed. It's not on the bottom of a fraction. So we can be greater than or equal to 0 here. If I solve this, I get x greater than or equal to negative 2. The nice thing about this is that just translates right over to your domain, and where you have the x, just say all real numbers. So this is all real numbers greater than or equal to negative 2. If you all are liking using the old domain notation, this would be a square bracket because you can actually equal the negative 2 to infinity. That would be representing everything from negative 2 to infinity, which is what we are saying here as well. So either one of those would be correct. Alright, if we move to example 7, again, I just set the inside greater than or equal to 0. Here I'm going to add 1 and divide by 3. So x has to be greater than or equal to 1/3. And again, that's a really easy move over to the domain. The domain is just all the x's that are greater than or equal to 1/3. So all real numbers greater than or equal to 1/3. Or you could write it in the old notation if you choose. Okay, now I want to talk about what happens if it's a combination. It's a fraction with a square root in the denominator, so it's both problems. In that case, the inside has to be greater than 0. Because it's a fraction, it cannot equal 0. Because it is a radical, it has to be greater than, so that we don't get i's. So number 8 is our example of a combination of a fraction and a square root. You take the denominator that's inside of the square root, and you say it has to be greater than 0, because we can't have i's and we can't have 0 on the bottom. So then all I have to do is subtract. I get x greater than negative 4, and therefore my domain is all real numbers greater than negative 4. So again, just try to keep straight when it is not equal to, when it is greater than, and that should make sense with rules that you have used in the past about fractions and square roots. Okay, I'm throwing number 9 in since we're talking about domain. This is a little bit different than all the other problems, and this is actually very simple. This is when you are given a specific domain. Here we're given just the numbers 0, 1, 2, and 3, and we're given a function, and they want us to come up with the ordered pairs represented in this function using just this domain. And so it's very simple. All you have to do is plug in. So plug in each one. I'm going to plug in 0. That would be absolute value of 0 minus 2 times 0. Well, that's 0, this is 0, and 0 minus 0 is still 0. That means this gives me the ordered pair 0, 0. Because what I plugged in, the x value that I plugged in was 0, and what I got out was 0. Then I move to the 1. F of 1. I do the absolute value of 1 minus 2 times 1. So this will be 1 minus 2, and that's a negative 1. So my ordered pair, I plugged in 1, I got out negative 1. Just think about in and out. Then I do 2. F of 2 be the absolute value of 2 minus 2 times 2. So I have 2 minus 4. That would be a negative 2. Therefore, my ordered pair is 2, negative 2, because I plugged in a 2 and I got out a negative 2. And then the last one, f of 3, I have absolute value of 3 minus 2 times 3. So I have 3 minus 6 gives me a negative 3. My ordered pair would be 3, negative 3, because I plugged in 3 and got out negative 3. And so that's what they were asking for, the ordered pairs, and this is my answer, all these ordered pairs. If instead of ordered pairs it had said what is the range, if it had said that, then your range, you could list in that same notation that the domain was in and just list those outputs. And again, it's a really similar worded question. It's just if instead of ordered pairs they had said range, that's what your answer would look like. Pay attention and read the directions to make sure you answer correctly. That concludes this lesson.